Thank you so much, everyone, for making yourselves available on a Friday to come to one of our final webinars for calendar year 2024. My name is Tim Penney. I'm an Aviation Safety Advisor and I work with CASA down here in the Melbourne office. Welcome to our webinar, which I'm certain that you will get something out of. The webinar that we're looking at today, we have some special guests from the Bureau of Meteorology, a couple of our aviation weather forecasters, and we're certainly grateful to have them along, and I'll introduce them a little later. But we've entitled this webinar, Mastering Aviation Weather Forecasts, and this webinar is part of our ongoing pilot safety campaign, which is hosted on CASA's Pilot Safety Hub, which you can find right on the homepage of our website. So we're currently looking or going through that period of our rolling pilot safety campaign where we're drilling down into and looking at weather and forecasting, which impacts so much of what we do when we go out and do aviation. Part of this is explaining and sharing with people all throughout the industry a whole wide variety of information and resources that have been made available to pilots and industry Australia-wide, essentially to help us as aviators make better decisions and also manage our own risks a little bit better. And these events are also a wonderful opportunity to hear from industry experts like Rebecca and Michael later on this afternoon. And as I said earlier, I'll introduce those our special guests a little later. So just a few little bits of housekeeping and other rules of engagement and bits and pieces before we actually kick things off. First of all, we certainly do appreciate your time. Thank you so much for taking the time out of what most people have are busy days, especially for those people that are running aviation businesses. To take time out from your afternoon or morning, depending on where you are around Australia, is certainly appreciated. It's our intention to make these types of events short and sharp and to provide you with some real useful information in a short time frame. We do understand that people's attention spans traditionally are quite limited in the online environment. And we do understand that your time is precious, and we want to make this information and your time with us as useful as possible. We've actually muted everyone's microphones and turned their cameras off for the time being. We do this because we have well in excess of 100, maybe over 200 people likely to join us today. So it just acts as a way of helping the presenters if they're not having people cutting in and out with video and also with microphones. So we do certainly appreciate that, and it just makes things run perhaps a little bit better. As we've done with all of our other seminars and webinars, we're actually recording this webinar, and we're going to put the recording of this webinar onto our Pilot Safety Hub on the CASA website. And the link to the Pilot Safety Hub is directly on the CASA homepage. So you can go in there after the webinar, or if you miss part of it, and catch up on some of the information that our guest presenters are going to share with us this afternoon. So we do that with all of our products, or as many as we can. We put them on our website so people can actually use them at their leisure. And finally, if you look on the top of your page on your laptop or on your computer, you'll see a little chat bubble. If you click on that chat bubble, it'll open up a window on the right-hand side of your page, and you are more than welcome to put in comments, ask questions, bits of feedback, that type of thing as we progress through our webinar this afternoon. So please feel free to type in a message, and we have people standing by that will provide things like links and responses to these questions, or if there's a quick question that we can throw to one of our guest presenters, we certainly will do so. We will certainly try and get to as many questions as we possibly can. And those that we don't have time to answer, we will certainly get back to you, which we have done with previous webinars. And that's one of the reasons why we've asked for people's emails, etc., and as part of their registration. It's our intention to have our webinar done and dusted in about 45 minutes or so. We might go a little bit closer to 60 minutes, but we'll certainly have you out of here in less than an hour. So, what are we going to have a chat about today? Just put simply, the first point I want to just run past you is a little bit of an overview about the topic. I've got a couple of slides just to kind of launch this information that we're going to be chatting about. I'll provide a few key points regarding why we're actually doing this and why we've asked you along today, and why being able to correctly interpret and actually apply aviation forecasts is just so important to our aviation safety. I'll just provide a bit of an overview. Then it'll be my pleasure to hand over to our guest presenters, two wonderful individuals, Paech and Rebecca Ryan. They're from the Bureau of Meteorology. Both Michael and Rebecca are aviation forecasters that put together your TAFs and your GAFFs and your grid point winds and all those good things. And they'll take us through the nuts and the bolts as to how to interpret these products and why they are actually so important for our everyday flying. After they've had a bit of a chat to us, I'll wrap up with a few key points that we can take home with us, hopefully to maybe change our mindset, change our behaviour, give us more impetus or encouragement to go and actually dive into some of these products to make our flying safer. If we do have time at the end, we'll have questions and discussions where you can ask Michael and Rebecca issues directly, or we can take them out of the meeting chat. Please take advantage of this chat function during the presentation, and it's our intention to try and answer as many questions as we go. And then I'll conclude essentially with a bit of an advertisement for our pilot safety campaign. And as I said at the outset, we'll try and have this done and dusted in about 45 to 50 minutes. So let's start with a bit of an overview. Really, all our discussions about forecasts and weather, etc., it really begs the question, you know, why is this information just so important that it actually warrants its own webinar? At the end of the day, weather does impact almost every aspect of our flying. Almost every aspect of what we go and do as aviators is impacted in some way by the weather that we surround ourselves with. And forecasts are a vital part of our risk management. You know, weather actually influences so much of our flight planning and our risk management, and there are so many influences here. We could go on forever and ever. But here is just a few I want you to think about, just to kind of get your head around as to why it's so important. Weather really impacts on, for example, how much fuel we need, whether we can fly or navigate visually or not. It impacts on how quickly we arrive at our destination. Weather also influences things like the distance we might require to take off, where we can fly, how high we can fly, how far we can fly. And ultimately, weather does impact directly whether or not we should be even flying at all. It really does touch every single impact of our operations. Third thing I want to chat about is that many pilots still do struggle with the interpretation and the use of forecasts. It's a common message that we hear consistently from many, many pilots around the country, not just private and recreational pilots, but also commercial pilots as well, who find themselves still struggling with bits and pieces when it comes to interpreting and using products such as the graphical area forecasts and grid point winds and temperatures. And this, at the end of the day, can be quite concerning. It is a concern because it does run the risk of pilots potentially missing out on vital pieces of information, which is critical to the safety of flight. So therefore, recognizing this is an essential skill, is the ability to use and interpret forecasts to manage the safety of our flight. And that's why our webinar today will hopefully be a chance for all of us really to perhaps reinforce the importance of our forecasts, which is essential not only for our flight planning, but ultimately the safety of those people that we take flying. Just to expand on this a little more before I head off and introduce our Bureau of Meteorology guests, it's important to realise that aviation, of course, is certainly a dynamic environment, and the circumstances and the environment around which we fly is constantly changing. All pilots in command, at the end of the day, are responsible for managing our own risks. Okay. Our safety largely rests upon being able to continually manage risk and then make and apply good decision making. The third point I want to talk about here is that part of good decision making and risk management is being able to use and interpret forecasts. Information that really is vital to the safety of our flight, especially weather. Because we can't make sound and considered decisions without access to essential information. And weather forecasts are one of the most essential pieces of information we have at our disposal, if not the most important. All pilots, and it doesn't really matter whether we fly 3 times a day or 3 times a year, it doesn't really matter, need to know these crucial things when it comes to weather forecasts: how to access it, how to interpret it, and how to apply it. And that's just part of the privilege of having a pilot license or a pilot certificate. It's part of enjoying the privileges of your qualifications. The other thing I just want to quickly mention is that there are many accident reports. And unfortunately, they do highlight the fact that there was no evidence in many of these reports of the pilots in command having ever obtained any weather-related information before they went flying. Throughout a lot of our education campaigns and in our AvSafety seminars, for example, we use a lot of ATSB case studies. And a continual thing that we often see, and for weather-related accidents in particular, there's a number of those events. And unfortunately, weather-related accidents are usually tragic, where there was no evidence of the pilot accessing any weather information. But being able to interpret this information is an essential part of what we do as aviators, and that's why we're here today. Please be aware, before we really get into things, that this webinar is in no way a silver bullet by any means. But what we do hope to do is to refresh our knowledge and, perhaps even more importantly, highlight the resources that are available free of charge to all of us, which might allow us to bring ourselves back up to speed when it comes to forecasts. So it's my pleasure now to introduce Michael Paech and Rebecca Ryan. They're aviation forecasters from the Bureau of Meteorology, and I will let Michael and Rebecca introduce themselves. And I'm sure they're going to provide us with some really good information to help refresh our knowledge and also to point us towards those critical resources that will help us with our decision making and risk management. So what I might do now is ask either Rebecca or Michael, who's had a few technical issues from up there in Brisbane, to just take control of the presentation, and I'll hand over to them.
All right. Thank you very much, Tim. So I'm Rebecca. Oh, I've accidentally gone forward a slide already. There we go. My name's Rebecca Ryan. Michael is unfortunately still having technical issues as far as I can tell, because he's not online. So you've just got me for now. I'm one of the forecasters in the Melbourne Aviation Centre. So we look after aviation forecasts in basically the southern half of the country, so southern WA, South Australia, Victoria, Tasmania, and Western New South Wales. Michael works in the Brisbane Aviation Forecasting Centre, so they look after, of course, the northern half of the country, so northern WA, Northern Territory, Queensland, and New South Wales East. All right, so today we're just giving a general overview of a lot of the products that you would be using in your day-to-day weather briefings before you're planning your flights. So we'll look at GAFFs, grid point winds and temps, just have a quick overview of AIRMETs and SIGMETs, and go through some summertime hazards that you'll be seeing more on the forecasts in the next month. All right, so taking this typical northern GAFF as
I can
an
take that
example.
over if you'd like that, if that's okay.
Oh, you're back. Great.
I am indeed, yes.
I will handball the northern part to you then.
Okay, thanks very much, Rebecca. And sorry, everyone, I had a little bit of technical issues up here this morning, but all seems to be okay now. Beck, I just can't control it, so could you just go to the next slide, please?
Are you seeing the... Oh, I don't think I have control either. Sorry, I'll take back control. There we go.
And then I'll take it over now. Okay.
Yeah.
Okay, great. Thanks. So we're starting off with a typical northern GAFF. And look, first of all, we're going to look at these graphical area forecasts. And these forecasts, there's a lot of information on these forecasts. They require a lot of close scrutiny. And it's not generally you can do something in like 30 seconds, have a quick squiz over and go, yep, she'll be right, mate, off we go. There's a lot of information in there. It does take some time to get your head around what is it that we're trying to forecast. Look, in the offices, we often discuss the story that we're trying to tell with our forecasts. And that's true of TAFs as well, but particularly with our GAFs. We're trying to tell a story about the conditions that you may or may not be experiencing, or sorry, you may be experiencing on your flight. For example, we may pick a particular area A, where we go, look, you have no chance of being able to maintain VMC today in this area. So we're trying to tell a story. This is a no-go area for VFR flight. Or there might be an area where we go, this is wonderful for flight today. So we're trying to tell that sort of story. All right, so first of all, let's have a look at the at what the GAFF looks like. In the top left corner, you can see a map. This one is of northern Queensland, and the map has various areas on it and various labels. Underneath that, we have a box on the left for the assumptions, and so these assumptions appear on every single GAFF. Things like if you get caught in a towering cumulus cloud or a cumulonimbus cloud, it's assumed that you're going to be experiencing severe turbulence and severe icing. There's also assumptions in there that if you're above the freezing level and you find yourself in cloud, then you're going to experience moderate icing. There's also a little mention in there that as part of your planning.
Michael, I'm sorry, it's Tim here. We're just having some technical issues with some people not being able to see the slides as such. What I might do is just take back control from you, and I'll just run them from my desk, mate.
That sounds good to me, Tim. Thank you.
All right, so we'll just head back. There's the overview, and hopefully people can now see the northern GAFF, and I'm happy to click forward as you see fit, mate.
Thank you very much, Tim. Okay, so we're just talking about the assumptions box, and now I'll move down to the bottom left-hand side, or the bottom left box on this GAFF. And that's a box where we can put in some remarks. For example, if we need to correct a GAFF because things are better than what we're forecasting, we can put a remark in there. This is also the place where critical location forecasts occur. They occur in two different GAFs, the New South Wales East GAFF, where there are 3 critical locations for getting across the Great Dividing Range, and on the Victorian GAFF, where through the Kilmore Gap is the critical location to head north across the ranges. Importantly, in the bottom left-hand side of that, there is a phone number. Okay, that's a phone number that will link you directly to the forecaster who is looking after the area, both the TAFs and the GAFs generally within that area. And so if you need more information after reading the forecasts and you want a little bit more information, please call that number. It's not an automated number. It's not a general number. It's to the actual person who is looking after your forecasts. Up to the top right of this GAFF, you'll see the header and the validity time. So we issued 2 GAFs at any one time, one for the next 6 hours and then one for the following 6 hours. And the information on the header tells you when they are valid, all in UTC time. And then we come to the to the right hand, or the main box on the right. And now this is where the coded forecast itself lies. Generally, there is a lot of information here. And as I said before, it takes time to read, interpret what we have got on the forecast there, and then make decisions for yourself about the flight that you have ahead. They are in code. And look, as pilots, you are required to know what these codes mean. For example, we might have things like ISOL, which is short for isolated. I'm talking about up to 50% of an area covered by a particular weather group, or broken, BKN, for broken cloud, where between 5 and 7 octaves of the sky is expected to be covered by cloud, and then the different cloud types underneath there. So there's lots of information in code for a particular GAF. So Tim, next slide, please. We're going to have a look at this particular GAF in detail by looking at one particular scenario. First of all, looking at the GAF map that we've got there, we can see that we have 4 different areas, A, B, C, and D. So it's only 4 areas. First of all, we've got A, which is across tropical North Queensland along the east coast. So we have conditions in there that are reflected with forecast for A. We have B, which is a smallish area around the Whitsundays and offshore. We have C, which is an area around the southeastern side of this GAF. I'll make the note here that the conditions we have in C apply to all of C. There's a little sub area in there, C1, where there's something a little bit different that we want to highlight, but the conditions that we forecast apply for the entire C area. And lastly, we have D, which is the majority of the state out west. Again, we have conditions there. On this day, by the way, it was pretty much okay all the way through D, except there was a slight difference in D1, where we had a little bit of cloud. So let's have a look at a flight. We're going to consider a flight from Longreach in the central west. And we're going to be flying, it's from the bottom of that blue arrow or blue line all the way through to Bowen, just north of the Whitsundays. And looking at that flight, we're starting in area D, we're traversing through area C, and then we're finishing it up in area B. If you're making this flight, you might also contemplate, look, it'd be a little bit more scenic if I went from Longreach straight over to the coast, due east, and then up the coast itself. That might be a little bit more scenic, so we might want to consider that as well. But for the purposes of today, we'll have a look at this flight. So first of all, Tim, could you go to the next slide? And this is where we get to interpret the conditions in each of those areas. I haven't put D on the screen. That's because there was no cloud in D at all. It was a wonderful day out Longreach way. But as we traverse through area C, we can see we have got some weather. First of all, in C, note how the visibilities and the weather go from the best weather with the best visibility progressively down to the worst weather with the worst visibility. First of all, we have greater than 10 kilometres nil. That means there is, in areas in C, there are places where we have no weather. And throughout that whole area C, we've got scattered cumulus, 8,000 to above 10,000 feet, given these GAFs only go to 10,000 feet. So we've got some quite high base cloud. So generally thinking, look, the mean conditions or the standard conditions through C are pretty good. We've got 8,000 foot cloud and less than half the sky being scattered is covered with cloud. We have some smoke. The next one down, I do want to focus on the next 3, the showers and the thunderstorms. We have 5,000 meters isolated ISOL showers. So that code or isolated term means anywhere less than 50% of the area can be covered with showers. It's quite a range. If you can imagine, like 40 to 45% of the area covered with showers, there's a fair few showers around, but only 10%. You're going to have lots of gaps in there. The thing to interpret though is isolated means you can mostly find your way through. In those showers, we've got some isolated towering cumulus looking at the right-hand side with the cloud. But the cloud, the towering cumulus has got bases at 7,000 feet. If you find yourself in a shower, you'll find yourself in a above that level in some towering cumulus. If you're below that area, we're expecting some stratus cloud underneath it, and it's broken. Going further down, yes, Tim?
Yeah, Michael, I've got a quick question. Gareth has written in and said, the way it's actually written, why does it say, for example, D1 only after the information, rather than before it? Because if it was written before it, it might, according to Gareth's question, it could be ignored without having to read it first, saving time. I don't know.
So generally what we do is any of those sub areas, we put into brackets to follow. Again, going back, I think people misunderstand that the conditions apply for the entire C domain. Okay, so that's in C1 as well, so the entire domain, but there's something a little bit extra or special that we want to highlight in the sub area. So for example, you're looking at that isolated thunderstorm one, 2000 ISOL TSRA. So we've got up to 50% of the area covered with thunderstorms, and we've got the cloud associated with that. But in C1, we have occasional. Now, occasional means anywhere from 50 to 75% of the area may be covered by thunderstorms. So if you are considering taking the scenic route across C1, which was, if you just stuck back to the previous slide, Tim, and if you can see, C1 is just to the south. At the moment, our track is going north of C1, but if you decide to go coastal, you may well be going through C1 itself, and so experiencing some occasional thunderstorms, probably a no-go zone. Thanks, Tim. Back to that past slide again. And also in C1, we're highlighting that we could also get the bottom row there, that we may get some thunderstorms with rain and hail in that area too. So at this stage, we're traversing C to the north of C1, so we can expect some isolated showers and thunderstorms in that area. As we approach into Bowen, we go into area B, and just to summarise very quickly there, we have showers on the forecast there, some isolated showers and some smoke, and we also have some cloud in there. I want to make one comment about the cloud. The first line you can see there under the greater than 10 kilometre nil, the nil weather line, is we have some scattered stratus from 1,000 to 2,000 feet over land, but only starting at 09 Zulu. So that's probably if you're getting in the late afternoon, early evening. The comment I'll make is scattered stratus. If you are flying above that stratus layer and you come across say a 20 nautical mile by 20 nautical mile block of stratus, it's probably going to look broken to you, especially if it's sitting above your destination. However, our perspective when we're looking at the whole area via satellite, I guess from our vertical view, we're looking at scattered cloud through there, but it does depend on your perspective, and we recognise that depending on what aircraft you're flying and where you are, that will mean different things. So Tim, that's enough from me. I'll pass back to Rebecca, and she can talk about some southern GAFs.
Thanks, Michael. So if we can go next slide, please. So here we've got a typical southern GAF for Victoria. So this was a day with a cold front approaching from the west and strong north to northwesterly winds ahead of the front. Now, look, I know it was a cold front day, but you might be asking, why is there no front marked on the GAF? Because we do put fronts or troughs on the GAF at times, but we'll only do that if the front is within the area at the start of the validity. So for this GAF, that would have been if there was a front in the area at 23 Zulu, but on this day, the front was coming through a little bit later, so you just kind of have these areas that are roughly in the shape of an approaching front coming in. So like for Michael's GAF, we've got 4 areas with various sub areas included in them for this GAF. If you could go next slide, please.
That was a good question, actually, Beck. I think we got a question earlier talking about, why don't we see fronts always displayed on the GAF? But it's only at the time that the thing was
yeah, it's only
issued.
yeah. So when we do put a front on a GAF, it will have a position and then an arrow showing the direction it's moving, as well as how fast that is expected to move. And so the idea is that you know the initial location of the front, and you can track where it should end up by the end of the period. No, that's
fine. Look, and one just quick one. Please clarify the abbreviation OCNL as occasional. I think Michael said that it could mean 50 to 75% coverage in the area.
That's correct. So
right,
occasional is the same as scattered, but it's the word we use for thunderstorms and towering cumulus instead of scattered. So ISOL 0 to 50, scattered or occasional 50 to 75, and then we also have frequent or widespread, which is above 75%. You don't see that quite as much, but you do see it. when we have
Lovely.
big systems coming through. All right, so for this, let's drill into this GAFF a little bit. If we can go next slide, please. So I thought today we'll just have a look at two potential flights. So the first being going from Point Cook, south of Melbourne, heading west towards Warrnambool. So as we did before, we just take stock of which areas that flight goes through. So it starts in B and also within sub area B1 and goes over west into A. Next slide, please. So here we've got A and B for us to look at. Let's start in B because that's where the flight starts, and we can see again the prevailing conditions are greater than 10k nil for the visibility, no weather, with some scattered stratus at 2,000 feet. Noting also that the cloud in the GAFF is always listed above mean sea level. So for this scattered stratus, say if you were traveling up to Ballarat, which has an elevation of about 1,500 foot, that's 500 foot stratus. So that's just something to keep in mind always when you're interpreting the GAFF as well. But anyway, for this flight, we're not doing that. Scattered stratus 2,000 foot. We've also got some rain coming from 03 Zulu. We've got some scattered rain with a fairly high visibility there, 8,000 metres, which has just got some scattered stratus and broken Q at 3,000 foot accompanying it. And then we've got some heavier rain, this 4,000 metres isolated rain, also from 03, noting that that's got some broken 1,500 foot clouds. So that's getting a little bit, the conditions are deteriorating a bit further with that one. And then in the final section, that's when we see that we've got some Sev Turb as well, just till 01, but Mod Turb coming on again from 03 Zulu. And so that's in the B1 area, which is where we start. So when you've got Sev Turb or Sev Ice on the GAFF, you also need to make sure you're, of course, checking your AIRMETs and SIGMETs as well, because if there's severe turbulence, there will be a SIGMET out as well for that. And SIGMETs are updated more regularly than the GAFF, so they're at least every 4 hours. That area will be revised and updated. So just make sure you're checking those as well to make sure you've got the most up-to-date information for now. Anyway, so we go through B, head out to A and take stock of the conditions there. So the cloud is a little bit lower in the mean conditions. We've got some 1,500 foot scattered stratus, but that is tending broken from 03 Zulu. So this is starting to put a little picture together of, okay, as we go into the afternoon, conditions are getting worse. We've got the rain coming, we've got stratus starting to lower, but also as we head west, conditions are getting worse, which makes sense if you know a front's coming, but even just from reading the GAFF without knowing that, you can kind of piece that puzzle together. So similarly to B, we've got two areas of rain, a higher visibility light rain and lower visibility isolated heavier rain. But in A, both of those have low cloud attached to them. So if you are in some rain, you would expect to see those worse conditions of 1,500 foot stratus or 1,000 foot stratus, both broken. In addition to that, for A, we've got some isolated heavier showers coming on from 02 Zulu with some very low cloud. We've got 700 foot stratus there. So and the turb in A is only for A2, which is not where we're flying. So, so to draw that all together for this flight, we're expecting scattered cloud, 1,500 to 2,000 foot, getting more broken as we head west and into the afternoon. Rain and light rain coming on from the afternoon as well. Again, conditions worse with the rain as we head west. Showers developing and some severe and moderate turbulence around. So, I mean, it's not looking too promising for this flight, but just to kind of illustrate how you kind of piece that picture together step by step. Could you go back 2 slides, please, Tim?
Sure. That one and that one.
Oh, sorry, I meant one slide then. Pardon me. All right, so the second flight that I just wanted to quickly go through would be if you were actually heading north from Melbourne, this time from Moorabbin up to Echuca. Because in this flight, you can see Moorabbin's just within Area B and B1. So if you go ahead 2 slides this time, please, Tim. So again, you would take stock of what's in B, but as a pilot, I'm not a pilot, but if I were, I'd be asking myself, okay, I'm right on the edge of the area. I'm planning to leave this afternoon. Is the rain going to be right at the edge at the time I'm going? And that's where I would pick up the phone. You can see in the remarks section our phone number, as Michael was saying, and that's there for when the GAF isn't giving you quite enough detail. They are very broad, so please do pick up the phone, give us a call and say, look, I'm leaving Moorabbin at 2 Zulu. It's right on the edge. The showers are supposed to be coming an hour after that. What's the chances of it coming earlier, later, whatever, and we can give you a briefing on that. For the rest of this flight, areas C and D, the main hazard is, again, that severe turbulence. So I think probably it still wouldn't be a great day for doing that trip, but yes, the severe turbulence. And of course, flying north, you'd want to be checking your critical location, Kilmore Gap, in this case, CAV-OK. And remember that if there was cloud, it would be listed above mean sea level. So you would need to remove that elevation listed. The Kilmore Gap 1200 foot is 1200 foot up. So you'd need to remove that 1200 foot from whatever the cloud was on the forecast in order to understand how much space you would have. Thank you. I think that's it for those ones. I think the next slide might be back to Michael. Yes. Thanks.
Thanks very much, Rebecca. So we're moving on to the grid point winds and temperature charts. And we've got an example of one there up over New South Wales. Again, it's like the GAFs. There is a lot of information on here, a lot of data to work your way through. And so first of all, we are looking at information of wind speed and wind direction and the various temperatures at various altitudes across whatever flight you are intending to take. Back when I was learning to fly, which was a long time ago, I had to get a wind vector, which I had to draw onto my circular flight computer back in those days, which you managed to manipulate to finally work out your ground speed and hence your fuel used, the heading you had to take, and so on. So this is a way to get that wind vector to put into your planning. So just have a look at this. We've got the legend down the bottom left-hand side of the chart, which appears on every GPWT forecast, but I've just blown that up in the top left. Now, what we've got is 6 lines of text, and they represent the different altitudes. The bottom line is the winds and temperature at 1,000 feet. Next one up is at 2,000 feet, 5,000 feet, 7,000 feet, 10,000 feet, and then flight level 140. So they're going up from the base to the top. You'll notice over on the eastern side of New South Wales, we've got a few gaps in the 1,000 and 2,000 foot winds, and that's because we've got the Great Dividing Range in the road there. And if you're flying at 1,000, 2,000 feet there, you're in a little bit of trouble. All right, let's pick a square, maybe just north of Echuca. Probably hard for me just to, Tim, maybe if you could highlight perhaps one of those squares there. That one there is perfect. And so if we look at the one just above that one there, perfect. So what we've got there is on the left-hand side, we've got at 1,000 foot, we have the number 27. Now that refers to the direction that the wind is blowing from, or 270 degrees. So they are written in 2-digit form. That's 270, so a westerly wind. And the next 3 numbers there indicate the wind speed at 19 knots. And then the next number across is it's 12 degrees Celsius at 1,000 feet. And then we do the same thing going up the next one. The next one up here is like 270 again, so a westerly at 20 knots. And we have a 10-degree temperature there. Going to the very top one, flight level 140, Tim. We can see we've now got 226 or 260. Again, basically a westerly wind blowing at 46 knots. and we're above the freezing level, we're at -11. So this is a product that gives you that vector that you can use for your planning. It is based on the Australian access model. There is no forecaster involvement in this. This is an automated product that comes out directly from that model. And from what we understand, and anecdotally, we hear that generally these winds do correlate pretty well once you're aloft. Sometimes the models struggle with right on the ground itself, but generally above the surface, those winds seem to ground truth relatively well. So let's have a bit of a look at a flight from Echuca down on the Murray, down the border between Victoria and New South Wales, and up to Dubbo. And then we've got to look at how we're going to get there and what grid squares we might go through. And therein, you look at that and go, well, there's my problem there. I don't know where they are. So you can go to the next slide, please, Tim. If you go to the Bureau of Meteorology website, and if you go to the grid point winds and temperature and select reference chart, at the top of the area you're using, you can download a map, which is at the same size as the GPWT grids themselves. And then you can overlay one on the other, which is what I've done on the next slide, Tim. And then we can now use this overlay then to find out what the winds and the temperatures are doing along your route. Unfortunately, if you're going from Echuca through to Dubbo, you are flying through 4 different squares, and so then there are slightly different winds along the route. And on this day, it's pretty much westerly right through New South Wales. I think this was a wintertime one, so it was a relatively easy one to follow. So I might leave grid point winds and temperatures there, Tim, and moving just with time in mind, we'll move on to the next slide. We want to have a look at another part, a really important part of planning, which are AIRMETs and SIGMETs. So an AIRMET is a warning or advice that we produce when we see deteriorating conditions that are not on a current GAFF. Okay, so typically there'll be things like a thunderstorm will pop up just outside the area that we've forecast for. So it's outside what's on the GAFF, or it could be fog, low cloud, icing, or turbulence. One of the common ones that we often push out in the summertime in the north are occasional thunderstorms. We may be forecasting isolated thunderstorms, but then a big cluster of storms breaks out in a particular area, and we've only got isolated on the GAFF itself. We want to highlight that in this area here, we've actually got greater than 50% coverage of the area. So that's a fairly common one that we put out in the north during an afternoon during the summer months. So this information here is fairly important to get. You can see on the right-hand side of the slide there, that's an example from about 2 or 3 weeks ago where we had some unforecast fog in eastern New South Wales and into western New South Wales that persisted longer than we expected. I think on that day we had fog finishing at 23 Zulu, and it just went a little bit longer than that. And also on that day we had some broken low cloud that persisted just a little bit longer as well. So how do you get this information? Next slide, please, Tim. First of all, it is really important that you access this information prior to flight. It's part of your planning. So if you're looking at the GAFF, okay, is there something that's had to be issued to update that GAFF? So to find them, when you're in NAIPS, if you go to the chart section in NAIPS and just when you're in charts, just search for Airmet, and you'll get up the products that you need. Both, you can either get the graphical product or the actual worded product as well. Alternatively, you can go to the Bureau website section under Aviation Weather Services and Aviation Warnings, and you'll get the same information there. If you're in flight and we issue an Airmet, ATC broadcasts on the various frequencies that required when they get that Airmet, and then 15 past the hour and 45 past the hour until that Airmet expires or is cancelled. So they will get broadcast in flight. Next slide, please, Tim. Same deal for SIGMETs. SIGMETs are a hazard for aviation that is, it's a significant meteorological hazard that can affect flight. We have strict criteria for what we need when we're providing SIGMETs. There'll be like extensive thunderstorms, maybe thunderstorms that extend greater than 100 nautical miles in length, or greater than 75% of an area is covered by storms, or sometimes even thunderstorms that are embedded in a rain band because it's going to be difficult to see the storms. Severe turbulence, severe mountain waves, severe icing. If there's a dust storm or a sandstorm, not just raised dust, but an actual storm, that's a SIGMET. And a volcanic ash, which has been out recently, and heaven forbid a radioactive cloud, but if that does ever happen, that's a SIGMET as well. Next slide again, Tim. And again, looking at how we can access these SIGMETs prior to planning, and it's the same thing as the Airmet. Again, it's under the charts section within NAIPS, and you just type in SIGMET, and you'll get either the graphical or the worded product, or again on the Bureau of Meteorology website under Aviation Weather Services. If a SIGMET is issued while you are in flight, ATC makes directed transmissions directly to the flight for those that are eligible. And normally I think that's an IFR flight that they get that directed to them within 2 hours flight time. So that's Airmets and SIGMETs. And with that in mind, let's move on to the next slide. That's a fairly brief overview of those. And we'd like to finish off today, Rebecca and I, just with some typical summertime hazards. Given that we are well and truly into the summertime at the moment, we'll look quickly at thunderstorms, the monsoon, fronts, fires and dust. Some lovely satellite photographs you can see there. Top right was a tropical cyclone. I've just forgotten which name it was, sorry. It's got a lovely little eye off the Western Australia coast. We're not going to talk about those today, but again, I'm hoping that no one will go anywhere near them or fly them. On the left-hand side, this is a satellite photo from 2020 from the extensive fires we had around the east or the southeast of Australia during that year. That was just a terrible year when it came to smoke, and you just see how extensive it was from what we were seeing on our satellite. And then the bottom one is a dust storm from 2009 that was moving through Queensland. 2009, again, what we are seeing from satellite. Next slide, please, Tim. I won't spend much time on the thunderstorms and the monsoon because there is plenty of other information out there on the CASA side as well. So I'll just briefly touch on them. Thunderstorms, the hazards are you get extremely severe updrafts and downdrafts and wind shear, and that is the wind shear is what really has led to probably most of the fatalities that have been associated with thunderstorms. We've got severe icing, we lose visibility, we've got broken low cloud, large hail, lightning, and also considering wet runways. Look, in short, as I say, you want to stay away from thunderstorms. We work on a safe distance from a storm of around 20 nautical miles. And so that means when we are issuing SIGMETs, we are working on a distance between cells of about 40 nautical miles, 20 nautical miles from one storm to 20 nautical miles to the other one. So that's the criteria that we use for issuing SIGMETs and the distance away from thunderstorms. Next slide, please, Tim. Again, I'll just briefly touch on the monsoon for those of you who are flying over northern parts of Australia. The monsoon occurs, maybe 3-4 times a year up in the north, and that lasts for anywhere from one day to a week. And it's characterised by a really deep northwesterly airflow. Mostly it comes from, in fact, it does come from the northern hemisphere. So this very moist air has travelled many tens of thousands of kilometres or miles to get there. What we have is frequent squally showers. We get days and days of low cloud and low visibility, and just the occasional, the odd thunderstorm, which is often embedded within that rain. So it's often difficult conditions within the monsoon. Again, just note again that there are plenty of other information, wet season briefings that are online for you to view with these hazards. I'll hand back to Rebecca now for the remainder.
Thank you. Next slide, please. All right, so of course, for the southern half of Australia, fronts are one of the main hazards we deal with. So can bring showers, rain, thunderstorms, causing visibility reductions, low cloud, hail, of course, icing, and particularly over summer when we can get the dry fronts come through, strong winds ahead of the front can be a real issue, not only causing turbulence, but along the wind change, having wind shear or gusts kicking up dust or in bad bushfire seasons, obviously causing havoc with fires as well. Next slide, please. Speaking of those fires, coming into summer, just need to be aware of how we include smoke on our forecasts, because smoke is the main aviation hazard that we're dealing with, causing visibility reductions. So not only can we have it impacting the surface visibility, but also what we call the vertical visibility. So that's where you have a layer of smoke, a thick layer of smoke kind of acting like a cloud sitting under the inversion. So in this example, also from that summer 2019 to 2020, you can see in the remarks section of the GAF, we've included this line saying sky obscured by smoke, thick layer of smoke between 2,500 feet and 6,000 feet in the southeast of New South Wales. So that again, that's above mean sea level. And within that layer, we'd expect visibility to be 0, like in a cloud. On the TAF, we also include this if the layer is sitting below 5,000 feet. So you can see on this Merimbula TAF, we've got the surface visibility at 7,000 and then VV, vertical visibility, at 2,500 feet. So what that means when you're coming in to land at Merimbula, above 2,500 feet, you'd expect visibility to be 0, like you were in a cloud. And as you come down towards the surface underneath 2,500 feet, visibility would likely be 7,000. And noting we've also on that TAF got a couple of probs for worse conditions where with worse visibility, but also lower vertical visibility ceiling there. Other hazards, of course, that we can sometimes get are pyrocumulus or pyrocumulonimbus. So that's where the fire environment locally causes enough uplift in the air to form either cloud or thunderstorms within the smoke. And so that's one that is very hard to forecast. It's very localized, and where you would definitely want to be keeping an eye on your SIGMETs and your AIRMETs in case we've either put out an AIRMET for unforecast storms or SIGMET for obscured storms where you can't see them in the smoke. And finally, next slide, please. Oh, second to last slide, sorry. Dust is the other one that we tend to see more over summer, where obviously once it gets dry and any kind of strong wind or gusty conditions can kick it up. Obviously causing visibility reductions, can also, I believe, damage aircraft through abrasion or static. And of course, we start to see more dust devils as well, bringing risk of turbulence. So definitely, yeah, keep an eye out for those on the forecast in the next little while. And next slide, please. Finally, if you do want to know more about our forecasts, our products, or weather, or just information about the weather, we do have a knowledge centre on our website in the Aviation Weather Services section. So do have a look there. We are reviewing and updating a lot of these brochures at the moment. So expect some updates and even new brochures to come out between now and Christmas. So definitely worth checking out. Next slide, please. And finally, if you do have any feedback, please do scan this QR code. Let us know what you think, any questions, requests, that kind of thing. We do get so much out of being able to improve our service based on what you actually want and need. So that's all from us. Thanks very much.
Thank you so much, Beck. There's some really good information in there, and yes, we are going to put this presentation on our Pilot Safety Hub, so people can go in and chew over it and look at it at their certainly at their leisure. So really, just to kind of wrap up this, and a few little key points that I just want to leave you with. First of all, thank you to Michael and Beck for giving us their time and expertise. It really is good to collaborate like this, because we can certainly all learn from each other. So what are the key things we want you to take away? What are some of the key things that you need to perhaps put in your kit bag, especially for the summer flying season? At the end of the day, as pilot in command, you are responsible. You're responsible for knowing how to interpret and apply weather forecasts, because the safety of yourself and the safety of those in your aircraft certainly depend on this. There's really just no getting around that fact. The second thing, be proactive. Please be proactive and don't just throw our hands in the air and think that it's all too hard. I know, of course, that if we don't fly as often as we'd like, or it's been some time since you were last current, interpreting forecasts can feel sometimes all too hard, and that's just a normal human response. Of course it is. But just leaving it at that and throwing our hands in the air and saying that it's all too difficult, it's actually not an option. As pilots in command, we need to know this stuff. So pilots exercising the privileges of our hard-won qualifications, we need to know how to access, interpret, and use this vital weather information. But in many ways, the good news is that there are a lot of resources out there to help us. But those resources are of no real use unless people are actually going to access them. And it might be an old-fashioned word nowadays, but all pilots in command need the discipline and commitment to their own safety and the safety of their passengers, of course, to be proactive enough to go and seek out those resources. And the Bureau's Knowledge Centre really is a great place to start. And there has been a link to that Knowledge Centre, I understand, just being put in the chat just before. These resources are free of charge and are available 24/7. So all we have to do as pilots is go and take advantage of them and access them. Please call the Bureau to seek clarification or to ask questions specific to your own operations. The aviation forecasters are more than willing to have a chat to you. In the bottom of each GAF, you'll find a phone number for the Aviation Forecasting Centre relevant to your part of the world. Help them to help you by being as specific as you can with your questions, and therefore they can tailor their responses specifically to what you're wanting to try and achieve. But also help them as well. If you see something out there that isn't forecast, give that number a ring and let them know. I was once on the north coast of Tasmania, near Wynyard, near Burnie there. A big sea fog rolled in from Bass Strait. It wasn't forecast, but a quick call to the forecasting centre in Melbourne resulted in amended forecasts. So please don't be frightened to give them a call. More than willing to chat. Practice makes perfect. There's nothing wrong with us downloading these forecasts and interpreting them and even putting together mock flight plans, even if we're not going flying. And practice looking at these forecasts with different types of weather events. If there are bushfires in the area, if there are thunderstorms in the area, a quiet day, a busy day, practice really does make perfect. And please be aware that, we all have gaps in our knowledge. And there's no shame in having gaps in your knowledge. But what is not okay is to recognize that you have got gaps in your knowledge, but then just decide to ignore them. Okay? We shouldn't be faced with shame or ridicule, of course, if we acknowledge these gaps and take proactive steps to fill those gaps. That is actually awesome, and that's being a professional pilot. But what's not okay is to have these critical gaps in our knowledge, such, for example, not knowing how to correctly interpret a forecast, but then decide to either guess or just do nothing about it and still go flying. At the end of the day, we want all pilots to aim to be excellent. We might not ever get there, and of course there's no such thing as a perfect pilot, but it's the effort and commitment to keep getting better. That's actually what really counts. So by committing yourself to learn how to more effectively read and use forecasts, you might just have prevented what could have been the final link in an accident chain, and that's pretty important. So just to wrap up, for those of you that have been to our webinars before, you may have seen this previously. We're putting out digital badges that recognise people's commitment to be with us and improve their professional development. And you can add those digital badges to your email signatures or onto a resume or social media, etc. So if you've stayed for the duration of the webinar, you'll receive a badge pretty soon after on your email that you can actually use as you see fit. And finally, just before we sign off, just a quick little plug once more for our Pilot Safety Hub. The motto of our Safety Hub, which has been now going for over 2 years, is your safety is in your hands, and it's up to all pilots to take the initiative and make use of all the resources that are being put out by all of our aviation safety agencies. It doesn't matter if you fly for private reasons or recreation, if you're an instructor or a commercial pilot. It doesn't really matter how current you are. We can all aim for excellence and commit ourselves to trying to better our knowledge, and the Pilot Safety Hub is a really great place to start. Other topics on our hub include non-controlled operations, flight planning, and controlled aerodromes and operations. And you'll find links to all sorts of information, webinars, podcasts, videos, etc., not only from here in Australia, but also from our international partners around the world. So please join us for our next webinar, which will be advertised in the coming weeks. And you can please keep up to date with our webinars by hitting the subscribe to our newsletters tab right at the bottom of the CASA homepage and clicking on the AvSafety seminars box. Please keep leaving us comments in that chat window. We do download them all and we do consider them all. We will get back to you if there are any questions that we didn't get round to. We've gone a little bit over time, but there was a lot of information to get through. So I certainly hope you thought it was worthwhile. I'd like to finish just by saying a big thank you to Michael and to Rebecca from the Bureau of Met. Thanks for their time and expertise. Many of our aviation meteorologists, they're all shift workers. They work 24/7. So for them to find this time in their schedule to put these things together and get out there and send us this information, we're certainly appreciative of it. So whether you're negotiating the wet season up north or enjoying the warmer weather down south, please everyone have a great summer of flying. Please fly safe, and we'll see you next time.